Good morning. Good morning. So, ସମସ୍ତଙ୍କୁ good evening. Today we will discuss the post-graduate diploma in analytical chemistry program. Paper code is MCH-2, and under this program you have 12 units, and sorry, under this course you have 12 units, and under your program you have four courses: MCH 01, 02, 03, and 04. And I have undertaken the second course in CS02. So this is all about separation technique. Okay, and the first unit is your the general aspects. So why separation is required, and what is the aim of separation methods, and what are the different advantages by separating the impurities or the undesired part of a mixture or a solution from a solution. So in this unit, we have introduction, objective, separation methods, and method science. Yes, followed by your evolution of scope of separation method, evolution of chromatography, very important, chromatography technique, and we have the classification based on property resulting in separation. Under this category of properties, we have volatility, solubility, partition, ion exchange, surface activity, molecular geometry, electromigration, and also classification based on equilibrium and rate processes. This includes your kinetic part, that is chemical kinetics, and then we have criteria for selection of separation methods. So on what property, based on what property we will select the type of separation process or method which are adopting to separate different component of a mixture. So this method, we have the selectivity, detectability, reproducibility, yield, speed and convenience, capability for hyphenation, ease in scaling of an economics. Then we have the summary part. So the main objective of separation technique is all about it is the process by which a mixture is divided into minimum or at least two components, because a mixture is formed by the combination or mixing of minimum two components. So if we go for separation technique, then minimum or at least two components get separated with same or different composition. If it is different composition, then it is okay. If it is same composition, they must have the different stereochemistry. So chemistry, stereochemistry, that is deals with stereochemistry, that is deals with your dextro and levo or type geometries, that is D or L configuration based on the orientation of your surrounding groups in an organic compound. Then we have analysis of different constituents of a mixture, procuring pure material from complex mixtures, removal of interfering constituents before the actual quantization of one or more known compound, isolation of unknown constituents for subsequent characterization, analysis of a complex unknown mixture by subjecting the entire sample to separation into individual constituents. So these are some objectives of this unit, that is why we are separating different components of a mixture, and depending on the various properties, the select separation methods are selected for separation of components. Then we have it is also for obtaining the pure material from the complex mixture. It is also separation. When constituent with the desired purity may be obtained by applying a single process or using a number of separating techniques. So I have a just a uh, PowerPoint presentation for you. I think this will help us to understand the things clearly, the why separation is done, and what are the different aspects of separation. Okay, so we have Jitendra Kumar with us. So Jitendra Kumar, where you from, and tell something about you. So give your introduction. Jitendra Kumar. Are you here, Jitendra? Am I audible?
जी सर।
Yes, yes. Where are you from?
सर बीप साउंड आ रही थी बीच में, उसके लिए मैंने किया था मैसेज। अब क्लियर है?
अब क्लियर है तो? अभी क्लियर है मेरा साउंड?
यस सर, अभी क्लियर है।
ओके, तो आप कहाँ से बोल रहे हैं?
जी मैं राजस्थान से हूँ।
ओके, तो आप पीजीडीएससी कोर्स क्यों ज्वाइन किए?
जी सर।
ये कोर्स क्यों आपने ज्वाइन किए हैं?
मैं इंडस्ट्री, मैं
अच्छा
पेंट इंडस्ट्री में हूँ ना, तो
अच्छा अच्छा, तो दिस कोर्स विल हेल्प यू। ओके
जीसी और एसपीएलसी के लिए एक्सपीरियंस दिखाना था।
ओके 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 ओके, तो आपका वो जो इंडस्ट्री, पेंट इंडस्ट्री में क्या आपका जॉब प्रोफाइल है?
मैं क्वालिटी एग्जीक्यूटिव हूँ।
अच्छा, तो पेंट का क्वालिटी आप चेक करते हो?
जी।
क्या क्या पैरामीटर्स होता है पेंट में?
पेंट में एलएबी वैल्यू होती है, वो चेक करते हैं।
NAV.
ऑयल एब्जॉर्प्शन वैल्यू,
ओके ओके ओके।
पिगमेंट, मैं रॉ मटेरियल टेस्टिंग में हूँ।
हम्म।
तो पिगमेंट्स आते हैं, आयरन ऑक्साइड आता है, रेड ऑक्साइड आता है।
हम्म। तो आपका केमिस्ट्री बैकग्राउंड है?
जी सर, बीएससी केमिस्ट्री से।
अच्छा ठीक है। तो फ्रॉम विच यूनिवर्सिटी और कॉलेज?
एमडी यूनिवर्सिटी रोहतक।
अच्छा अच्छा। तो आपका ये फर्स्ट सेमेस्टर है शायद पीजीडीएससी में।
जी।
और आपने पहला जो MCH-3 साइड आपका प्रोग्राम हो चुका है, वो क्लास वो आपने कर लिया, अटेंड कर लिया?
हाँ, वो प्लस के।
इससे इससे पहले आपका एक क्लास था शायद ये वाला था, MCH-4 था, इलेक्ट्रो एनालिटिक्स एंड
एमसीएच
अदर मेथड्स। ये वाला
एमसीएच
आपका हो
फोर
गया?
था।
आप सब क्लास अटेंड कर लिए?
हाँ, डेली अटेंड कर रहा हूँ क्लास।
तो अभी बाकी के बच्चे कहाँ गए? अभी तो 2 ही बच्चे ज्वाइन किए हैं इसमें।
सर डेली इतने ही आते हैं सर।
वो डेली नहीं आते हैं?
जी।
ओहो। लेकिन जब एग्जाम होता है तो बहुत सारे बच्चे एग्जाम देते हैं पीपीडीएससी में, मैं देखा हूँ। और ये
सर
कोर्स तो इंडस्ट्री पर्सनल के लिए बहुत ही मतलब पॉपुलर कोर्स है इग्नू का।
डेली सर 3-4 ही रहते हैं।
ओके 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 ओके। तो आज क्लास होने वाले है, आपका ग्रुप में मैसेज किया तो आपका मेल में मैसेज दिया होगा?
नहीं सर, ऐसा कोई ग्रुप तो नहीं बना रखा मैंने।
नहीं, आपको मेल गया होगा ना, पर्सनल मेल में गया
हाँ।
होगा।
हाँ, मेल आया हुआ है।
मेल आया था ना, ओके। तो बाकी के बच्चों में भी गया होगा। तो आप राजस्थान के किस तरफ रहते हो?
मैं एनसीआर में, भिवाड़ी ना, जो
हाँ हाँ हाँ।
हरियाणा टच में है,
अच्छा
भिवाड़ी में रहता हूँ।
अच्छा। तो आप हम जो आज डिस्कशन करेंगे, दिस इज ऑल अबाउट सेपरेशन टेक्निक।
जी।
So from a mixture, on the basis of different properties like volatility, solubility, their boiling point, melting point, depending on that, we are separating the different components of a mixture. So today is the preliminary class or basic class about what is a mixture, what are the different physical or chemical parameters on which where we have to decide what type of separation techniques or methods we will adopt to separate the different components of a mixture. Okay. So based on we have the most simple technique that is known as filtration in our lab, where we are separating the soluble components from the insoluble components of a solution by just simple filtration by using a funnel and filter paper. So, filtration, we have different separation techniques or methods, and which are selected and depending on different physical or chemical properties the or the we can say or the different component we are expecting from a mixture that will be used in our further research or further lab work. So just I am pointing out the different important points in your PDF unit 1, and these are the fundamental things that go through these things. What are the daily in our daily life? What are the different techniques we are using, right? And if we are in our breath, the different particulate matters can be separated by our nasal, and only oxygen is allowed to go inside our respiratory tract. So in this way, filtration again the most important or most popularly used separation method is chromatography, which is very popular because in this technique This technique was developed by Sweld, and this technique is all about separation of different components depending on the distance traveled by different components from its reference point. We will discuss one by one different chromatography techniques like uh, gas chromatography, liquid chromatography, then thin layer chromatography, gas liquid chromatography, and your separation membrane chromatography, ion exclusion chromatography. So all these are pure chromatography. Okay, so just see here one PPT I have. This is just the fundamental of your separation method. That is how different components of a mixture get separated using using different separation techniques. So is this visible, Jitendra and Vijayalakshmi?
जी विजिबल.
Okay, just wait. It's good. So this is all about your how to separate a mixture. So explain the difference between compound and mixture. So a compound is we can say a compound is the union of two or more elements in a definite proportion, but a mixture is a combination of compounds. It is a mixture. So we will separate that compounds by different separation techniques. So this is the primary classification of a matter, that the matter can be defined as anything in this universe that has mass and occupies some space is known as matter, and on the basis of its composition it is of two types, pure substance and mixture. If it is a pure substance, it may be of two types, elements and compound. So elements can be defined as it is the purest or the simplest form of matter which cannot be simplified into still simpler form. And a compound is defined as it is the union of two or more elements in a fixed ratio. So either element or compound both belongs to your pure substances of matter. So in mixture we have two type of mixture, homogeneous and heterogeneous. For example, if water is added to milk, it may be categorized under your homogeneous mixture, and if sand is added to water, then it may be treated as a heterogeneous mixture. That is, two different phases or two different states gets mixed, so that is your homogeneous and heterogeneous mixture. Then we have the C here in a black tea, or we can say in a tea. What happened? Substances and mixture which are in a single phase known as homogeneous mixture, and when different substances are in different phases or states, this may be treated as heterogeneous mixture. Then we have type of mixture. We have the mixture may be miscible, may be immiscible, may be soluble, may be insoluble. If it is miscible, then it is capable of being mixed. If it is immiscible, it cannot be mixed. If it is soluble, that means it will dissolve in the said solvent, and it is insoluble means it cannot be dissolved. So this is a primary equation for a solution where it is copper sulfate pentahydrate salt or solute. It is now dissolved in water, to give a solution of copper sulfate, which is blue color. So this is also known as blue vitriol, that is CuSO4.5H2. And this a solution is another word for homogeneous mixture. That is when water and the salt gets dissolved, then both are converted to a single phase. That is your liquid phase. So part of solution is your solvent as well as your solute. Solvent dissolves the solute. Solute is what is being dissolved. So this is a very fundamental thing. So in aqueous solution, generally what happens, the solvent which is used is generally water. An aqueous solution is solution in which water is the solvent created by dissolving substance in water. AQ next to a substance being dissolved in water. So NaCl aqueous means NaCl table salt dissolved in water. So AQ stands for your aqueous solution. So mixtures are separated by physical means using different physical properties, what we are already point out. Some properties, namely density, melting point, boiling point, solubility, volatility, viscosity, surface tension or surface energy, then we can say osmotic pressure. So like this, what happened, different type of physical properties, the mixture are separated accordingly. On the following slides, we will investigate three methods of separating mixtures. For each method, you will turn to your partner, discuss how to. So this is just one. This is the first one, which already pointed out. There is a filtration. This is a basic method of separation in our labs. That a mixture of water and sand, which is a heterogeneous mixture. If I wish to separate the water and sand, I may use one simple filter paper and a funnel. Then what happens? The water gets separated from the sand, and the sand will be deposited as a residue on the filter paper, and the water gets separated from the heterogeneous mixture as the filtrate. So lower part is the filtrate, and the thing that is remain in the on the filter paper, it is known as the residue. So this is a common method of filtration separation. So filtration is a separation method used to separate pure substances in mixture made up of particles, some of which are too large enough in size to pass through the filter paper. So depending upon the type of residue you wish to separate, uh, then accordingly the type of filter paper is used. So we have different four size of filter papers like Wattman 41, Wattman 42, Wattman 1, Wattman 2, and ordinary filter paper we have. So in our house, home, or offices, or any bank, then nowadays due to continuous or increase in temperature of the environment or atmosphere, air conditioner is or AC is commonly used. So in AC also they have used some filters which restricts the the pollute particles or impure particles from the atmosphere to go inside the air conditioner. So this is also the use of filter paper. And one is distillation method. So in this method, the dissolved salt in ordinary water gets separated by using a very common chemistry apparatus or chemical apparatus or glassware in our lab, uh, that is the production of or separation of demineralized water from ordinary water using distillation plant where uh, Just wait. So distillation process, it is a common separation method used in our labs to prepare demineralized water from ordinary water using distillation plant, where a round bottom flask is used, a burner or a Bunsen burner is used, followed by the condenser chamber, and the water gets evaporated, and then the water vapors are condensed and continuous tap water is flowing inside the condenser to make the water vapor to water particle by cooling the water vapors, and finally the demineralized water gets collected in our. So distillation is a procedure by which a solid and a liquid or two liquids with different boiling points can be separated using the process of evaporation and condensation. So evaporation takes place inside the round bottom flask, and condensation takes place inside the condenser. So these are the two examples where the ethanol and water solution gets separated. So ethanol boils at 74.4 degree and water boils at 100 degree centigrade. So accordingly, we have to separate different boiling points. So ethanol will separate first, followed by the water. And this is fractional distillation method, where a crude oil gets separated by using this method. And the crude oil contain the components like gas, that is CNG, you can say, that is refinery gas, petrol, naphthalene, kerosene, diesel, lubricant oil, fuel oil, and electricity. So all these components present in crude oil that is collected from the earth crust or from the sea or ocean. Okay, these crude oils under fractional distillation. So fractional distillation means depending on their boiling point. Just wait. Depending on their boiling point, they get separated. So the component which has the lowest boiling point will separate first, followed by the boiling point which have the highest boiling point will separate at the end. So this is known as the fractional boiling point, the fractional distillation method. So this is a very good example of how the boiling point separation carried out using fractional distillation separation technique. Then we have, yes, this is a very advanced technique of separation of different components in a mixture, that is known as chromatography. So chromatography was introduced by Michael Swelt. Okay, so just see his just wait. Just see, he is Michael Swelt. Okay, so in 1906, the Russian botanist Michael Swelt introduced a new phenomenon of separation, which is known as chromatography. So he separated chlorophyll and other pigments in a plant extract by using this technique. And in 1906, this chromatography technique created history, created a big revolution in the field of separation methods. So, on the basis of his principle, different advanced modern chromatography analytical instruments are nowadays available. But the principle, the fundamental, the basic of separation technique is framed by Michael Schell in 1906. Okay, so according to him, when a mixture is having different components, so this is known as paper chromatography, where chromatography paper was used to separate the different components in a mixture. And this paper chromatography, in this technique, so at the lower part of the paper, we just lay out a dry line that will be treated as the reference line, and we put the mixture. Here we put ink, and you may put 2 or 3 drops of the mixture by using the dropper or your glass tube. Then after, and this paper is now called as the chromatogram. Chromatogram means the surface on which the chromatography phenomenon occurs is known as chromatogram. So this chromatogram is now put under a solvent. The solvent may be ethyl alcohol, may be acetone, may be ethyl propionate, maybe. Okay. So depending on the type of mixture you are try to separate, accordingly the solvent is chosen. Okay, it may be benzene, it may be organic, any organic solvent. So then what happen? If you put your chromatogram or paper inside this solvent, then gradually the solvent will go up because the paper will get wet. If the paper will get wet, then then with the solvent, this the different component present inside the mixture gets one by one separated depending upon their attachment to the solvent. That means the component which is strongly held will remain at the bottom, and the component which is loosely held with the solvent or loosely bound with the solvent will go up. That means the component which is above, it is loosely bound, and the component which is below, it is strongly bound. So this is how your retention factor is calculated, which is known as the RF value. RF value is distance traveled by the component divided by total distance traveled by the solvent. It is known as the retention factor. So depending upon the retention factor, you are now able to know what type of different components present in a given mixture. So this is all about your chromatography. So I just read out the components in the mixture have different attractions with the chromatography paper. Therefore, the different components travel up the paper at different rates, depending upon their attachment or type of bond or type of attraction between solvent with the different component. Then this is a common instrumentation of chromatogram or chromatography, where one carrier gas was there, which will create some pressure inside the chromatography instrument. Then we have the injector, and this injector, this can be this is used to inject the sample inside your chromatogram. This is the chromatogram we have. Okay. Then and when the sample is injected, and depending upon their uh, attraction, or depending on their attachment towards the solvent, different components get separated one by one, and they are decoded, or they can be recognized using this detector. And we have a monitor here which will show what the number of component or the type of component the sample has. Okay. And in this part I just forget to mention one thing, that in chromatography experiment or separation, we have two types of phases. One is known as stationary phase, and second is known as mobile phase. So in paper chromatography, the paper that is known as the stationary phase, which is static, and the solvent is known as the mobile phase. Here, the mobile phase is running on the stationary phase, and with this passage of running, different components get separated one by one depending on their attraction or bonding or attachment to the mobile phase. So here we have two type of phases. One is solid phase and one is mobile phase. So this is the instrumentation we have. Well, in real life, gas chromatography is often used to investigate criminal cases like the ones featured on those shows. This can take the form of crime scene testing, the analysis of blood or both samples, arson verification, that is identification the chemical responsible for a fire to see whether there was foul play, or blood testing after death to determine level of alcohol, drug or poisonous substance in the blood. So this chromatography is very much advanced chromatography to separate the presence of alcohol or any drugs or poisonous substance, whether that is present inside the blood in a crime or not, can be tested using this advanced system. Then this is one your question answer. To obtain drinking water from muddy water, we can be filtration, maybe a separation technique. To separate gasoline, it is your fractional distillation. To remove leaves from a swimming pool, we may use a simple filtration. To obtain pure sugar from a solution, we may use crystallization. To determine whether the color in a fruit juice is a single substance or a mixture of colored substance, we may use chromatography. So this is just a just an exercise for you. So this is your Michael's swell. Okay. Uh, then after him and Michael Swelt also termed the first technique, which is known as liquid solid adsorption chromatography, where liquid is treated as the mobile phase and the solid is treated as the solid stationary phase, and the phenomenon occurs is your adsorption. Adsorption, what is adsorption? The the settlement of solid particle or any particle on the surface of an adsorbate is known as adsorption. Okay, like inside a trolley, we may say the small packets of silica or silica gel are there, which is used to absorb the moisture content inside the trolley. So this is the phenomenon of adsorption we have. The same phenomenon is used in liquid solid adsorption chromatography. Then we have ion exchange chromatography is there, where the ion gets exchanged. We will discuss one by one in the next classes. Then we have partition chromatography where partition coefficient is calculated, and gas chromatography where different gases are. Calling south. Please mute yourself. Please mute. Okay. Well, okay. So up to this, any doubt, Jitendra, Vijayalakshmi or Farin, anything
No, sir.
you wish to clarify? Is it understandable? Is it okay?
जी sir.
Okay, okay. So then simultaneously or parallelly, we will move your PDF also, that is PDF. Then we have one Nobel Prize winner in 1952, that is Martin and Sinch. These two gentlemen, their recognition in this pioneering work in this field, and they have introduced the chromatography in different areas of sciences. Okay, so they received the 1952 Nobel Prize for chromatography technique. Then, as I already stated, chromatography is having two phases: stationary phase and mobile phase. So one phase uh, remain as such, no change is there, or in position will remain fixed, and the mobile phase will move up or down with the different components along with it. So depending on the adsorption, partition, ion exchange, and a side exclusion, we have different type of chromatography techniques, which we will discuss in our later part. The classification of separation methods, so depending upon the separation goal or diversity of mixture to be separated, the utilization of a variety of physiochemical phenomena for separation. So depending on the the aim we have or the goal we have, then accordingly the separation of components from a mixture is carried out. So the separation named after the forces of phenomenon that give the rise to separation. For example, precipitation is a separation technique where, for example, when your silver nitrate HCNO3 is added to simple hydrochloric acid, it will give silver chloride. Silver chloride is separated as precipitation, white precipitation. So in this way, we can extract or we can separate silver particle from your silver nitrate solution by using hydrochloric acid. So second is crystallization technique where the crystallization, like in sugar solution, if I wish to separate the sugar, I just put it under the heat and crystallization will develop. Then extraction will happen. Extraction is also a separation technique which is used to extract. Let us oil and water gets mixed. Then, with the help of a syringe or with the help of separating funnel, we can separate or we can extract the oil from the water depending on the density. So the liquid substance which is having the higher density will at the lower part, and which is having the lower density it will be about to act that one. Then the absorption phenomenon where the surface on the surface different particles get absorbed and they will separate according to their absorption property. Then we have the ion exchange, and we have size exclusion. This is also another chromatography, size exclusion chromatography, where different ions get separated on the basis of their sizes. The smaller ion will separate first, followed by the bigger ions. So the if an equilibrium process is there or rate process is there, so this is depends on the kinetic part. So the rate at which the separation will be done depend upon the type of component present in a mixture. So based on the property resulting into separation based on equilibrium or rate processes. Then we have uh, property, we have volatility, solubility, partition, ion exchange, surface activity, molecular geometry, and electromigration. So under volatility, let us we have two in a mixture we have 2 to 3 components having different volatility rate. Then we may use the that one. Which one? The distillation process, where ethanol and water gets mixed, and ethanol is having the boiling point of 74.4 degree, and water is having 100 degree centigrade. So when heat is applied, ethanol gets or the ethanol gets into the vapor state. Um, Vapor state, then the ethanol is separated first, then after that the water is separated. So this is the volatility. So where the volatility is more, the component with higher volatility will separate first. Then the solubility. Solubility means in a definite or in a particular solvent where two or more solute gets soluble, then depending on their solubility they get separated. The one which is having higher solubility will separated at last, and the one that is having lesser solubility will separated first. Then the partition, so they are depending upon their partition coefficient or partition, different components gets separated. Ion exchange, so the ion gets exchanged from my mobile phase to solid phase, and from solid phase stationary phase to mobile phase. Then accordingly their separation will done. In surface activity, this is depends on the adsorption phenomenon. So where adsorption is there, that means the different particles gets adsorbed on the surface of adsorbent, and depending upon their on their what is known as the that is your strength of adsorption, they get separated. Then the molecular geometry, it plays a vital role in separation technique. The molecular geometry means the molecule having the bulky nature will separate first, and the molecule is having a definite smaller geometry. Smaller geometry means it is maybe sp, sp2 or sp3 hybridization. Then they may be separated at the latter part. Then electromigration, this is like electrophoresis. So electromigration, that is cathode and anode will be there, and your electrolyte having different components in ionic form gets migrated towards their opposite end. That is positive charge migrates towards cathode and negative charge migrates towards anode. So accordingly, your components gets separated. Then, if for volatility, we have the separation method: fractional distillation, flash distillation, vacuum distillation, steam distillation, and isotopic distillation. So just read out all these distillation processes, very simple ones. Then solubility, we have solvent solubility, having some chemical reaction like barium sulfate. If you have the barium sulfate, sorry, if you have the yes, that is barium chloride salt, and you just add sulfuric acid, then your barium sulfate will form, which is having the white precipitate, and accordingly it gets separated. In partition, we have liquid-liquid extraction, liquid-liquid partition chromatography, and gas-liquid chromatography under this one. So then we have ion exchange already. This ion exchange chromatography is used uh, in your high capacity water purifier, high capacity demineralized water plant, where your ion exchanger, that is anion exchanger and cation exchanger were there, and you just input or you just inlet the ordinary water, and in huge quantity you will get the demineralized water for industrial purposes. So in uh, demineralized water plant of high capacity, that is 500 liter or 1000 liter per hour, or per 2 hour, this ion exchange chromatography is used. And also in our domestic, that is aquaguard water purifier, yeah, the technique that is reverse osmosis is used for separation of different insoluble components present in ordinary water. That is your osmosis. The process is known as osmosis, where a semi-permeable membrane is used, and the water purifier which contain high quality SPM semi-permeable membrane has the high value or high price than the ordinary one. And inverse osmosis is the phenomenon which takes place for separation of different insoluble components or insoluble particles in ordinary water, and which gets separated, and we are getting the uh, drinking water. Then surface activity is all about your adsorption. So where two things are there, one is known as adsorbent and one is known as adsorbate. So adsorbent, it is a stationary phase, and adsorbate is the liquid mobile phase. So adsorbent is the surface, like the stationary phase, on which the particles gets adsorbed, which are known as the adsorbate. So like our paper chromatography, we have a solid liquid adsorption chromatography and gas solid adsorption chromatography. So here liquid is treated as the mobile phase or adsorbate, and solid is the adsorbent stationary phase. And in the second one, gas is the mobile phase or adsorbate, solid is the stationary phase or adsorbent. So we will discuss in our block 2, unit 7 and 8, and unit 5.6 also there. In this units will discuss the details of this chromatography technique. Then molecular geometry, as already point out, depending on the size of the molecular geometry, we have different type of separation methods. There are a number of methods based on molecular geometry. They require a permeable barrier to provide separation. The methods may be molecular sieve or gel filtration, and we have the membranes, that is known as microporous membrane, homogeneous membrane, charged membrane, and thin membrane. And under these membranes has also huge applications. That is maybe ultrafiltration, reverse osmosis. This is already discussed. That is your semi-permeable membrane is used here, SPM, and dialysis for dialysis purposes and electrodialysis. So for these life-saving processes, your membrane chromatography is frequently used. For water purification, starting from water purification to electrodialysis, and this membrane separation or membrane chromatography is very important. Then gel filtration or gel formation or size exclusion chromatography, where the particles get separated depending on their size. So the particle has the smaller size will separated first, and the bigger size particle will separated at the end. Electromigration, this is all about electrophoresis, here it is written, or it is also known as electrochromatography, where the migration of ions is towards the opposite end in an applied electric field. That means cathode or positive ion will migrate towards the cathode, and the negative ion migrates towards the anode. It is known as electrophoresis, and it is under your electromigration. Then your slab electrophoresis, a filter paper is used. A capillary electrophoresis, a capillary tube is used. So, depending on the type of stationary phase we have, the chromatography is accordingly named. So this is the kinetic part, that is equilibrium and rate process. So in on equilibrium process we have gas liquid, gas solid, liquid liquid, and liquid solid chromatography. So this is known as GLC, GSC, LLC, and LSC. So we have different type of chromatography technique depending on the equilibrium process. That is the equilibrium between liquid, that is the mobile phase, and the stationary phase. And in equilibrium chromatography or equilibrium process, we have two phases. One will act as mobile phase, and the second will act as the stationary phase. So in gas liquid, gas is the mobile phase and liquid is the stationary phase. In gas solid, gas is the mobile phase, solid is the stationary phase. In liquid liquid, one liquid is stationary and one liquid is mobile phase. In solid liquid, liquid is the mobile and solid is the stationary phase. So accordingly, you just try to remember and try to understand that which phase will behave as the liquid phase, a mobile phase, and which phase will behave as the solid phase. Then, if it is gas liquid, then distillation and foam fractionation will be the non-chromatic method, which can be used to separate the two components. And if it is the same mixture, it is separated by a chromatography, then that chromatography is named as gas liquid chromatography or GLC. And similarly, for gas solid, the non-chromatic chromatography is sublimation and adsorption. For chromatography, it is GSC or exclusion chromatography. Gas solid chromatography or exclusion. Then for liquid liquid, we have liquid liquid extraction depending on its volatility property. And if it is your chromatography technique, then you have LLC, LLP, or HPLC. And this HPLC, high pressure liquid chromatography, this is a very advanced technique for the separation of different components in a mixture. Then liquid solid, for liquid solid we have precipitation technique as a non-chromatographic technique or fractional technique. But under chromatography method, we have the adsorption chromatography, the first one, that is a liquid solid, where one column or a planar plain paper, that is a mass planar, is used. Ion exchange chromatography, affinity chromatography, or gel formation or exclusion chromatography. So for liquid solid, this is for liquid solid type mixture, we may use this kind of chromatography technique for the separation of different components of a mixture. So this is your equilibrium. So based on the rate, we have different type of separation methods that can be adopted for separation of different components of a mixture. So the rate process, so this may be permeable barrier such as membrane, like your semi-permeable membrane which is used in the water purifier and obeys the osmosis process, that is RO, reverse osmosis. And we have different methods which are depending on the migration velocities, like your electrical, gravitational or thermal processes. Then different diffusion rate through permeable barriers, it may be ultrafiltration, reverse osmosis, dialysis and electrodialysis, these are already discussed. Then field separation, we have electrodeposition, electrophoresis, capillary electrophoresis and electrochromatography. This is the field separation we have. Field separation, this may be remember as the separation of different ions of an electrolyte. Through the chromatography technique, which is known as electrochromatography. And this electrochromatography um, may be termed as electrophoresis or electrodeposition also. Then we have the criteria for selecting the separation method. So depending on the goal we have, that what type of component are there in the mixture, or what type of component we are expecting from the mixture to carry out our research work or to carry out our future work. Then we may study the different physical properties, different chemical properties the mixture has, and on the basis of that property we may select different separation methods to separate different components of a mixture. So first one is the selectivity, that is the what type of component is there and how to implement different separation techniques through that selectivity point of view. Then detectability, third one is yield, that is the quantity of the product we expect, that the speed, that is the kinetic, and the convenience. So how easy or how difficult it is for us to separate the different components of a mixture. And capability of hyphenation is in scaling up or economic. So all these things are there, and these are some point of views, or these are some criterias we may keep in our mind to before selection of a separation method for a particular mixture to obtain different components from it. So the selectivity I just read out, on the selectivity related to the capability of the technique to separate the desired component effectively from a complex mixture, particularly containing closely similar components. This is very important. The term effective separation expressed in terms of resolution, separation factor, decontamination factor, and percentage purity. So, depending on the desired component, to separate the desired component to this component effectively, this selectivity is one of the very important criteria. Then detectability, reproducibility, that means it is producing again and again. So in the so keeping in mind these properties, you may choose or select different separation techniques according to your requirement. And what is hyphenation? In a majority of chromatography technique, there is a detector which quantifies the effluent coming out of the column. These detectors are not very sensitive. Also, they have a limited capability of identifying the unknown. It is known that a mass spectrometer is very useful for universal detector. Therefore, it is interfaced with some of the chromatographic technique like GCMS. Just remember, students, and in our recent moon abhiyan, that is made by ISRO, Indian Space Research Organization, and different spacecrafts were sent to different planets, that is Mars, the Moon, or Venus. Like different countries are trying to figure out or trying to decode the environmental statistics of different planets or asteroids. So they are sending this GCMS instrument. Just remember, the GCMS instrument inside the spacecraft, and this GCMS, it has a unique technique to find out what type of component is there in their environment, as well as simultaneously it can predict the mass also. So this is the full form of GCMS is gas chromatography mass spectroscopy. So this gas chromatography mass spectrometer, not spectroscopy, it is spectrometry. So gas chromatography mass spectrometry. So this is a very advanced technique or advanced tool to which is sent with the spacecraft by ISRO or NASA to know the environment or to decode the atmospheric ambience the planet or the asteroid has. And just I am wrongly pronounced that is spectroscopy. Why it is spectrometer or spectrometry? Spectroscopy is one that is the interaction between matter and electromagnetic radiation. So electromagnetic radiation, it is all about the radiations which are associated with both electric and magnetic field, which are perpendicular to each other, and they can propagate through vacuum, and their velocity is just same as the velocity of light. So these radiations are known as electromagnetic radiation. So when these radiations are interacted with matter, this is known as spectroscopy. But in mass analysis, no electromagnetic radiation is used. Rather, high energy or high velocity electron gets bombarded with the molecule to know the mass. So that's why mass, it is called as mass spectrometry, and other analytical techniques are known as spectroscopy. So there is a big difference between spectroscopy and spectrometry. Just remember this difference. So UV is a spectroscopy because UV electromagnetic radiation is used. IR is a spectroscopy, infrared. NMR is a spectroscopy where radio waves are used. But mass is a spectrometer. Okay. Then we have the most important thing, that is the economic point of view. That means what we are trying to separate, and by which method or which technique we are adopting for the separation, that matters. As we know, there is a small difference between mineral and ore. So mineral and ore both are same in the sense, but they are also different in economic point of view. That means anything or a mixture that is extracted from earth crust is known as mineral. But when the different components of that mineral get separated economically, then that mineral is now called as ore. So economic point of view, it is very important. So in any separation technique, we must consider the economic part. That if we are uh, collecting the component of 1000 rupees, and we are just what is known we are just to pay rupees 5000 for the separation, then that type of statistics will not be treated as economic one, and it is not be viable. So whenever you choose a separation method, the separation method must be economic in that sense. That means your amount or your price of the component you have collected must be greater than the technique you have adopted. That is known as economic point of view. Okay. So this is all about your unit one. and under your unit 2, okay, this is the solvent extraction method we have in your unit 2. So up to this, anyone having any question or anything wish to share, we will have some discussion. Kendra, Harin,
No, sir.
Vijayalakshmi, is it okay?
जी sir.
Okay. So in solvent extraction method, we have a one important rule that is known as phase rule. F equal to C minus P plus P, where F is degree of freedom, C is component, and P is the phase, number of phases. So this phase rule, then followed by the distribution law, we have distribution ratio, percentage extraction. Then we have different solution methods by different systems like for simple molecules, compound formation, solvation, ion pair formation, crown ether. Crown ethers are ethers which are just looks like a crown. Okay. Then diluents and modifier, etc., etc. Then like so, in solvent extraction, we have the concept of liquid phase, because solvent is generally in liquid phase, and they must be free from impurities. Okay. Then if chromatography technique is used, then we have the liquid chromatography, liquid extraction we have, which is also known as the solvent extraction. So liquid extraction is popularly known as solvent extraction. Then the primary objective of this unit: explain general principle and terminologies, what is solute, efficiency of separation, classify extractants used for metal ions, and the role of diluent and modifier. Yes, I am just 1 minute away. Thank you, students. So the liquid extraction is known as solvent extraction. So in solvent extraction, we must emphasize this on the partitioning of solute, efficiency of separation, extraction of used metal ions, role of diluent and modifiers in the extraction of metal ions. Then we have the phase rule consideration, that is F equal to C minus P plus 2. So, or it may be written as P plus V equal to C plus 2, and this rule was given by Gibbs. So where P is the phase, C is the component, and V is the variance, or which is also known as the degree of freedom. So, distribution law and its limitations, which is given by Nernst. The scientist name was Nernst. In 1891, he proposed this law, and according to this law, when two immiscible solvents gets or forming a mixture and one distribution solute, there is 1 degree of freedom. The ratio of the concentration of solute in two phases is invariant. Invariant means F equal to 1. Univariant. It is independent of the total concentration. So based on this, we have the equation, that is S1 to S2. That means it is your solvent 1 to solvent 2, that a particular solute is, it is distributing between solvent 1 and solvent 2. Then what is the distribution coefficient Kd? It is concentration of second solvent divided by concentration of first solvent. So then we have then for a saturated solution, he is just the small s is multiplied. Okay, so this is not needed. Then we have the equation, that is K dash, that is equal to your thermodynamic partition coefficient. It is equal to S2 concentration divided by S1 concentration, which is equal to activity coefficient, that is Y2S2 divided by Y1S1, and it is equal to S2 by S1 is your Kd. So that's why activity of second solvent divided by activity of first solvent into distribution coefficient. So this is your thermodynamic distribution coefficient. Okay, or we may rearrange the equation, that is Kd, that is distribution coefficient, is equal to y1 by y2 into y1 by y2 into k bar, sorry, k dash, which is the thermodynamic distribution coefficient. So just try to understood these equations. Then distribution ratio, it is equal to total concentration of solute in organic phase divided by total concentration of solute in aqueous phase. That we have two phases, aqueous and organic phase. So when the solute is added, then what concentration of solute is present in the organic and what concentration is present in aqueous. So the ratio between these two is now known as the distribution ratio. For example, in a distribution of benzoic acid between benzene and water, the equation is, this is benzoic acid in water, we get hydronium ion and benzoate, and in benzene phase, what happened? The benzoic acid get dimerizes to give HBZ twice. This is dimer of benzene. So we have the first one, that is AD HBZ, that means this one in aqueous medium. Then we may write the equation HBZ in organic divided by HBZ in aqueous. Then the second one, that is the benzoate ion, Bz minus. Then the same one, it is inorganic divided by in aqueous. Then Kd benzoic acid, the dimer, this one dimer, this will be inorganic divided by aqueous. So D equal to total benzoic acid in aqueous phase divided by total benzoic acid in aqueous phase. It is wrongly written. Total benzoic in organic phase, it should be organic, divided by the total benzoic acid in aqueous phase. So, so total benzoic acid in organic phase, it will be HBZ twice, HBZ twice, and HBZ organic. This one is BZ organic, and here we have HBZ and BZ minus. So this is HBZ and BZ minus. So these two are in aqueous phase. Okay. So accordingly, you just left out the water concentration and hydronium ion concentration because the water concentration is not taken into account as the amount of water is very high. So in aqueous phase we have benzoic acid HBZ and benzoate ion BZ minus. In organic phase we have two molecule of benzoic acid and one dimer. Okay. So then another example is there, osmium tetroxide between carbon tetrachloride and water. Just go through these things. These are very simple ones. Then percentage extraction. So this is very simple calculation that percentage extraction, that is of distribution ratio. This is known as percentage of E. So as we know, distribution ratio is metal present in organic by metal present in aqueous phase. So concentration of M, O means organic by A means aqueous. So D equal to this is your activity, or we may say it is the function divided by V0, VO organic phase divided by 1 minus F by VA. Then by simplifying these equations, we have the last part. What is F? F is the, yes, F is a fraction of the metal ion in the organic solvent at equilibrium. That means in organic phase, F is the fraction, then 1 minus F, it will be the aqueous phase. So in aqueous phase, we have the F by VO divided by, in aqueous phase, we have 1 minus F. So 1 minus F by VO. So F stands for organic and 1 minus F stands for aqueous. So by simplifying all these equations, at the end we have the equation that is percentage of E equal to 100 divided by D plus 1. Just trying to solve this one by tomorrow. If it is not, if any uh, doubt or problem you have faced, then you may ask me tomorrow. Okay. Then we have the relation between distribution ratio and percentage of extraction like this. We have the curve we have, then separation factor, which is symbolized as beta. So beta is concentration of component in organic phase divided by constant component in aqueous phase. So C1O by C2O divided by C1A by C2A. Okay. Then where C1 is the component 1 in organic and aqueous, and C2 is the component 2 in organic and aqueous. Then C1O by C1A, it is D1 distribution ratio, and this is also D2. So D1 by D2, it is your beta, that is for your two components, namely 1 and 2. In multiple extraction we have, it should be clear in mind that one transfer doesn't necessarily lead to a clean separation under this situation. So that means whenever a separation is carried out for the first time separation, the separation may not be 100%. So and it is may not be uh, pure also. Maybe some impure particles still remain. To separate out uh, the impurities, the second time, third time, fourth time separation may be carried out. So this is known as multiple separation, multiple extraction. Multiple extraction is successive portions. Then the two phases C1 and C2 uh, have the concentration W1 by V1, and C2 will be total weight minus W1 by V2. Then distribution coefficient will be in organic phase, that is C2, your W minus W1 by V2 divided by W1 by V1. Then at the end we will have the equation W1 equal to W V1 by dV2 plus V1. And accordingly the equations are simplified, and this is for n time extraction. This is the 2-time extraction. This is 2 times. If the extraction is carried out for n times, then Wn equal to W V1 by dV2 plus V1 to the power n. So this is how the weight of the solvent can be calculated. Then accordingly the percentage of extraction, it is also calculated. Then classification of extraction system, we have the following, basically the 3 stages: formation of an uncharged compressor extractable species, distribution of the extractable compressor of the species, interaction of the compressor of the specific organic phase. So first one is the formation of the complex, then distribution of the complex, then interaction of the complex. So there are 3 phases of extraction system. So this distribution of simple molecule, extraction by compound formation, extraction by salvation, extraction by ion pair formation. So the extraction will be carried out with different techniques after the distribution of simple molecules. So this is the distribution of simple molecule, like germanium tetrachloride or mercury dibromide or arsenic tribromide between aqueous phase and organic solvent. Then the extraction by compound formation. Then what happens? These molecules can be extracted by using a complexing agent to form a compound by using liquid cation exchanger. Okay. So we may use chelating ligands, which may form different bond, forming a cyclic type structure. Chelating agents or chelating ligands, and chelating complexes are exceptionally stable, so that's why chelating ligands may be used. Extraction by acidic organophosphorus ester or by carboxylic or sulfonic acids. Just try to remember these 2 or 3 agents which are used to extract the samples. So this is the chelating agent what we have already discussed, and under chelating agent we have EDTA, ethylene diamine tetraacetate ion, which is a extra hexadentate ligand. That means it can it can form 6 bonds with a particular metal center. So then some of the available market or commercially available in the market, some chelating agents are named as P5000 series, which is hydroxyoxy, KLX100 oxime derivatives. So under different commercial names, these chelating agents are available in the market. So in acidic organophosphorus compounds, the same reaction is carried out, but here the organophosphorus is used. That is the DEHPA, di-2-ethyl hexyl phosphoric acid. So this is used to form the complex with cerium or thorium, and accordingly it can be extracted. Then we have the carboxylic or sulfonic acid. So carboxylic acid is carrying the COH group, and sulfonic acid carries the SO3H group. So just see here, so these are the carboxylic acids. Okay, and uh, like hexatic or naphthalenic acid obtained from the distillation of crude petroleum are important. So these are some examples. of some acids which are extracted from different crude oils. This is naphthalenic acid. This is your versatile acid. Everything is written here. So these are the some general chemical reactions which are placed here, and how naphthalene extract reacts with metal with increase in pH. The order is this one. This is experimentally claimed that iron, copper, indium, cobalt, iron 2 plus and manganese 2 plus over pH 1 to 10. These metal ions are extracted by using this carboxylic acid or sulfonic acids. So extraction by solvation, this is also one of the important method of separation. So based on solvation of neutral molecular complexes, the electron donor containing extractions. So electron donor containing extractions are there, like sodium tetranitrate, diether, nitric acid. These are some code names are there. So these extractants are used to extract various solvent from their mixture, and this is under your solvation process. So reagents containing oxygen bonded to carbon, ether, ester, alcohol and ketone can be used, or we may use oxygen and sulfur bonded to phosphorus, like alkali phosphate or alkali thiophosphates. These may be used for their separation. Then using carbon oxygen bonds, there are reactions are there. Then these will provide a high concentration of complexing anion by the law of mass action. Water will bind to ions of salting out of salt, that is known as common ion effect. And then the addition of salt will lower the dielectric constant of water or in aqueous phase, favor the formation of association complex. So different physical or chemical properties may change in the extraction process of the solvent. Then a table is there. This is the organophosphorus, type of ester, and the type of compound is formed. So this is a very table. We read out these things. Then some extraction of ion pair formation is there. So when a compound in organic phase, it is now added with an acid H plus in aqueous phase, it will form a salt in organic phase as well as a ion exchange in aqueous phase. This is A minus A, this is the ion exchange. Anion exchange this one. So depending on the type of salt you have taken for this extraction, and accordingly their anion exchange regime or may have different orders. The formation of anion exchange regimes. Then I just point out the crown ether. Just see, this is known as the crown ether. It is not there. The crown ether is not here. Just see the. This is the crown ether we have. This is known as crown ether. Okay, this is just look like a crown of a king, where after every CH2 CH2 methylene linkage, or sorry, CH2 CH2, that is ethylene linkage, one oxygen is there. For this is just a repetition of 1, 2, 3, 4, 5, 6. So this is your 18 crown 6. So total number of atoms is 18. Crown 6 number of oxygen is there. So the name of this crown is 18 crown 6. So accordingly, just see here. Just see here. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . see here. It is 18 crown 6. It is 12 crown 4. It is now 9 crown 3. It is known as dioxane. That is known as what is 1, 2, 3, 4, 5, 6. That means 6 crown 2. It is 15 crown 5. So the total number of atom crown the number of oxygen atom. It is known as the naming of crown. So these crown ethers can be used to extract different solvents in a mixture. And the uh, unit of a crown ether is CH2O CH2. Okay. And these ligands also known as cryptans. Just try to remember this word, cryptans. And this will may form a cyclic like compound which is of exceptional stability due to cyclization, and the solvent can be easily extracted. Then we have the last part, that is diluent and modifiers. A common practice dissolve them in a soluble solvent known as diluent. So uh, when a extract or a solute or a salt is dissolved in a suitable solvent, that suitable solvent is known as diluent. So why diluents are used? They are mainly used to decrease the viscosity of the extract depending upon the metal to be loaded. Another role of diluent is to decrease the emulsion formation tendency. Diluent improve the dispersion and the coalescence property of the solvent. So, and it also it should have low volatility and a high plus point. This is the characteristics of diluent. So, what are the different physical and chemical property diluent should have to be act as a suitable diluent for a particular solvent or a solute to be extracted. Then is the modifier, which may be modified, and it may be in most of the cases the problem is to overcome by the addition of the third component known as modifier. So modifier is the third component. Just I read out this one. One of the very serious problem is solvent extraction formation of the third phase. There is two organic phase. Most of the available evidence on third phase formation suggested that it is essential to solubility problem. Invariably, it is the organic phase that split into two phases. Okay. So the organic phase is now split into two phases, and in addition to that, aqueous phase. That means it becomes three phases. So whenever the three phases are there, then three components will be present in that condition, and the third component is treated as the modifier. This helps to restore the organic phase to 1. Such modifiers are invariably isodecanol, 2-methoxyhexanol, p-nonylphenol, or PBP. And this is some characteristics, some examples of the modifier. Let's go through this modifier. And in the third unit, we have the solvent extraction 2. In this part, we have some metal chelates, solvation, ion pair, synergy, pH, molarity, metal concentration, salting out of agent, then masking, extraction. These things are there. These very common things are there. Just I have tried to complete this unit as soon as possible. And what is metal chelate? That chelate means it is the chelate ligand, chelating ligand is used. This is the chelating agent or chelating ligand is used. Like oxygen, it is a chelating ligand where two centers are there which can donate lone pair to metal center. And nitrogen is having a lone pair, oxygen is having two lone pairs. So that means this can be formed a cyclic like complex. And also diketone. Diketone is also a chelating ligand or chelating agent to form a chelating complex or metal complex. So this is the equilibrium we have, that aqueous to organic. So what is the distribution coefficient? That is organic concentration divided by aqueous concentration. Then the dissociation constant of HR, H plus and RA in aqueous medium. So S plus concentration into R concentration, R minus concentration divided by HR concentration. Similarly, when that R is now this R minus, this is the ligand part, or this is the donation part, that is chelating anion, R minus. So when R minus is now donated their electron to the metal center, then we will get MRN. So what is the formation constant? MRN concentration divided by Mn plus R minus to the power n. Similarly, the equations are made here, and we have the final distribution constant equal to MRN organic divided by MRN aqueous. And at the end, we have the equation this one, 3.10. So trying to understood these things. Very easy questions. Just remember, at the denominator we have organic part, and at the numerator we have the aqueous part. Okay. And we have the pH versus log D slope like this. Then extraction by solvation the same way. The uh, the using an extractant, we are separating different solvents in different pH range. So extractant with oxygen bonded to carbon, ether, alcohol, ketone may be used. Oxygen, sulfur, maybe phosphorus or alkyl phosphate, alkyl thiophosphate may be already discussed. Now this is some examples how the uh, iron tetrachloride anion in aqueous phase is extracted from iron hexamide hexaqua 3 plus salt. This is the equation we have. Then in this reaction, we have 4 steps having equilibrium constant K1, K2, K3, and K4. In the first equation, there are 6 water. From 1 water was separated, and we have 5 water. In the second reaction, we have 4 water. In the third reaction, we have 3 water, and in the fourth reaction, we have 2 water. Okay, so we have 4 equilibrium constant K1, K2, K3, K4. So the net equation will be 6 water change to 2 water, and the removal of 4 waters. Accordingly, the equilibrium constant will be concentration of Fe water twice Cl4 into water concentration per 4 divided by FeH2O, which is 3 plus multiplied by Cl minus concentration to the power 4. Only product divided by reactant. Similarly, formation of solvent. So how the solvent is now used, formed. So here we have this ion as the extract, and now this is reacted with the ether. Sorry, ether is the extract. R2O is the extract, and it is the mixture we have in the organic phase, and we have the 2 water molecule gets replaced by ether, and 2 water molecule gets separated. Then formation of the complex. So this hydronium ion reacts with the tetrachloride salt to form this complex, and this R2OH, this one R2OH will react with the ether complex to form this complex. At the end, we have the equation like this. Okay. So in this way, you just find these reactions, how different extractants are used to separate different ions from a solvent. Then extraction by ion pair formation. We have many type of ions that can be formed, like permanganate ion, that is KMnO4 minus, dichromethane Cr2O7 2 minus. So this is dissociation by reagent. Okay. So always remember, the from the equation, whenever you write the equilibrium constant or distribution constant, The product concentration is at the top or above, and the reactant concentration is at the bottom. Then there are four steps, that is dissociation of the reagent, formation of ion association complex, distribution of the reagent, and dimerization may occur. Then these are some examples. Actually, it is very difficult to cover 12 units within 4 days, and all the reactions, it is not possible to discuss all the reactions bit by bit, one by one. Yes, I am trying to clarify one example, and accordingly you are recommended to follow the rest examples accordingly. Extraction by synergism. Synergism is about the back bonding. Okay, back bonding. That is two extractants work together to increase the extraction by huge factor. Here, two extractants are used. For example, dialkyl hydrogen phosphate. This is one, and other one is TPP. So, the TPP is, yes, tributyl phosphate. So this is your tributyl phosphate, which is used as the second extractant, and accordingly, your reaction is your solvent is extracted. Okay, and the reaction is carried out. There are two extractants are here. Then factor if influencing extraction your pH, it is the scale which is used to measure the acidity or alkalinity of a solution or a substance, and pH mathematical equation is minus log S plus ion concentration. This ranges from 0 to 14, and if it is less than 7 it is acidic, greater than 7 it is alkaline or basic, and if it is equal to 7 it is neutral. Then molarity of acid, molarity is number of moles of solute present in a 1 liter of solution. Then accordingly, when the molarity of acid is high, then your pH will fall down, and accordingly your reaction is carried out. So these are some graphs how mole per liter inverse and your percentage of X, E, percentage of E are plotted. So just don't try to remember these plots, these compounds. Just try to remember the simple ones and write your answer in your examination. Effect of metal and concentration is also a important factor for a solvent extraction process. That whenever the metal ion concentration is more, then high uh, concentration of extractants need to be used for the extraction of the same. Presence of salting out of salt, like your production of table salt or rock salt NaCl from seawater. This phenomenon is known as salting out of salt. That is common and effect phenomenon is carried out where the seawater is gets deposited or uh, collected, and some ready-made salt just pour above that seawater, and after some time it is see that mm, uh, that solid salts are just formed from the seawater. It is known as the salting out of salt, and it is based on Lee-Chaptal principle, that is common and effect. Presence of masking agent, EDT is a masking agent, that is your ethylene diamine tetraacetate, which is having the hexadentate characteristics, and which is a chelating ligand. So it will mask the metal ion, and accordingly the extraction is carried out. And concentration of extractant, it is also one of the factor for extraction. Then we have nature of the diluent also. Different approaches for metal encephalography is stripping. It is a removal of extracted solute from the organic phase for further processing or analysis. It is known as stripping. So for that, this process, EDTA, citrate, tartarate, this type of extractants are used, masking agents are used, and pH of the aqueous phase, acidity, molarity, presence of masking agents, selective stripping. These are some factors uh, mm, which are used or which are having some effect on the extraction process. So pH of the aqueous phase, we have acid molarity in the aqueous phase, and these are some commercial names we have, some extractant, then some metal ions, their molar ratio, yeah, the acid molarity, and this Sinex, that is the toluene. Toluene having the benzene ring with CS3 group is known as toluene. And presence of masking is in aqueous medium, like organic phase, also in aqueous phase. The same things are there. Criteria for choice of organic phase: the component of the organic should be immersible, it should have good stability, a different density of the contacting phases is essential and should be a great as possible. Low power requirement, interfacial tension, solvent should cause no corrosion, solvent should have low toxicity, it should have high metal loading capacity, it should be easily strip of the loaded metal. So this is all about this unit. So try to figure out some examples of your masking agent, emitting agent, and your extractant. Uh, some simple examples from how one extractant is used for the extraction of the metal ion or the solvent we have. Okay, so this is how this unit is discussed. So now we have 2 to 5 minutes for discussion. So anyone having any question, you may raise or we may wind up the session. So it is actually very difficult to cover uh, 3 units or 2 units within 2 hours, and I'm just trying to uh, cover some of the important aspect of your block one, because you have 5 blocks in MCH-2 paper. You see here you have 5 blocks, and we have completed the first block today, and in due course of time we will try to complete these 4 blocks within 3 days. So that's why at the end I am bound to speed up the teaching process. So it is more or less important that what is your understanding, and depending on your understanding, you may write your paper very easily. And just trying to remember 1 to 2 examples only, not try to remember all the materials that are kept in your PDF. Okay. So anything you wish to share or any problem, any question you may ask, else we may wind up the session. Kendra, till that. Okay. So if no question is there, so thank you for your patience hearing, and on behalf of um, Regional Center Vigno Bhubaneswar, I thank you to all for your patientful stay in this discussion, and hopefully we will have effective discussion in the later classes, and the next class will be tomorrow, then day after tomorrow, then also. So now for the next 3 days we have 3 classes. Okay, so we have 1, 2, 3, 4, 5, 6 classes we have. So today we cover up block one, and in next 5 classes we will complete all these blocks. So we may wind up the session now. So thank you, students.
Thank you, sir. अपना सेंड बना लिए।